Oh man, I am on. I'm sorry about that. We are testing 1, 2, 3. Testing 1, 2, 3. Yes!
Oh man,
we got it.
We are testing 1, 2, 3.
Yeah.
2, 3.
That's what I'm talking about. Resilience, baby. That's what I'm talking about. Yes! We got it!
Yeah.
Oh, this is good. That's what I'm talking about. Resilience, baby. That's what I'm talking about. All right. Let's see if we can. All right. Good, good, good. I'm actually just watching mine here. I'm hoping you're able to see it. If not, then good night almighty. I have no idea what to do. We are kicking it live right now, and I'm pulling this up, making sure we're all good. I think I've just sent it out. I hope that as you join, I've got an extra viewer here, which means we are set and ready to go. Thank you so much for joining. Thank you for hanging with me. This is not going to cut into our review time. I'm just going to go to bed just a little bit later tonight. That's okay, because you are worth it, and I appreciate your help on this today. And so, yeah, I'm hoping that this will help. I'm going to try to look and make sure that the viewers are there. If for some reason I am unable to see this, or if you can't see it, or if you can't hear me, please let me know. If you could just put it in the chat box if you can hear me, just so that we have kind of have everything squared away on that. That would be great. Just shoot me a message just saying, Coach, can hear you. We're good now. It took me a little bit, but all good things take a little bit of time. And so we're going to get moving here today and get rolling. Care about y'all so much and just ready to get this thing on the road. So I'm just going to go to Remind 101 real quick. Make sure that I've sent it out. I think I have. I think I've sent this out already. But if someone could, really quick, just put in the comments box that you can actually hear me, that would be great. I think since we have viewers, I think that means that we're good. But if you could just in case, throw it in that comments box, that would be fantastic. Okay, let's do this. Let's get right straight into the problems today, because if you're anything like me, we want to make sure we use our time as wisely as we possibly can. And so what I'd like to do is just kind of go through these together. And so let's get started. Okay, let's get started here. So I'm going to mute myself here, mute myself. Perfect. Thank you, Jada. Appreciate your help there. Let's get rocking and rolling. First thing we want to do is let's start off with a few of these problems that maybe we've already done in a couple of your classes, maybe not. If you've got a specific question, I'm always open to those specific questions that are there. My whole goal of this is to be able to help you out the best that I know how. And in doing so, that means that I need to make sure I got feedback from you. So if you've got specific ones that you're like, hey, Coach, can you hit up on these? We absolutely can. And then we can kind of go from there, okay? The first ones I'd like to do here include the ones that are the non-calculator section, because this is the one that we're going to start on tomorrow or Thursday. So I want to make sure we go through this one first, these non-calculator problems. So let's get started. The first thing I want to do in number 11 is first identify with a non-calculator. What is my possible well, with my attempt to go P over Q, or last over first. So this would be 18 over 1. So what I can do on this one is then say, what are the factors of 18? Well, that would be plus or minus 1, 2, 3, not 4, 6, 9, right, and 18. So we've got these possible zeros. But what it does tell me is that the first zero is negative 3. So what that means is I could plug negative 3 in for this synthetic here and put the coefficients here, being sure that if I skip one, I fill that in with a 0. So I have 1, 1, negative 3, 3, and negative 18. So I bring the first one down, bring the value of 1 down. 1 times negative 3 is negative 3. I add here to get negative 2, distribute to get positive 6, Add here to get positive 3. Distribute here to get negative 9. I get negative 6. Positive 18. When added, we get 0. Cool? All right, so again, this just reminds me that here we are. We've got our values here with a remainder of 0. Now, some of you I talked to about factoring this down below, but if that confuses you, let's keep going with what we know. So it then goes on to say that 9 and 18 aren't zeros, so we're going to throw these two out. So that means that I've got to have another value. Sorry about that. Another value that when plugged in up here for my second, that would get me a remainder of 0 as well. So I'm trying to find something that gets me a remainder of 0, but to test that, we're just going to go left to right. So we're going to try 1. So bring down 1. 1 times 1 is 1. Add to get negative 1 here. This distributes to negative 1. Add to get 2. 2 times 1 is 2, which, oh, by the way, does not give me a remainder of that what I'm looking for, right? So we're looking for a remainder of 0. That does not really help me, so we're just going to erase that there, just saying, okay, we know it's not 1. Again, this is non-calculator, so be sure you know how to decipher that. Now we're going to go negative 1. We bring down the 1 value here. 1 times negative 1 is negative 1. We add to get negative 3. Negative 3 times negative 1 is positive 3. 3 plus 3 is 6. 6 times negative 1 is negative 6, which looks as though we've got a 0, but these actually are the same sign. So we just we didn't get that one either. And so we are get rid of that positive 1 and negative 1. Okay. And again, by the way, just so you know, put in the chat box the different questions you have. Feel free to put those on there. Okay. All right. So let's see. Again, I'll bring down the 1. Let's try 2. So 2 times 1 is 2. We add to get 0. 0 times 2 is 0. Add to get 3. 3 times 2 is 6. Oh, looky there. Look at what we've got. Remainder of 0. So right now we've got the zeros, or yeah, really these are x-intercepts, right? Negative 3 and 2. But what about these other values? Well, this number's by itself. This is with an x. This is with x squared. So really what we have is x squared plus 3 that we can set equal to 0. Now what do we do from here? Well, I can simply subtract 3, right? To get x squared equals negative 3, square rooting both sides. To get x equals plus or minus, when I have the square root of a negative, I bring an I out, I square root of 3. And we can leave it just like that to get 2 solutions, and then we have our 2 zeros. Remember, the amount of solutions corresponds to the degree of this polynomial. Cool? Cool beans. Hopefully this is helpful. I understand too, I am going to go by very quickly. So slow me down, stop me, tell me, coach, hold up, and we'll rock and roll, okay? All right. All right, let's go here. Let's go to this next one here. Let's go to number 12. Number 12, we have 4i up here. And the numbers next to 4i correspond to 1, 0, 13, 0, negative 48. So 1, 13, oh, I'm sorry, 1, 0, 13, 0, negative 48, okay? If you're confused on that, we could talk through that today or even tomorrow morning as well. So we bring down the 1. 1 times 4i is 4i. Now, here's the kicker. Be sure that you look on the homework and even on your quiz, because there was one where you would be able to combine this, and we'd actually have 2 values. But because it's 0, we just simply say, okay, this is 4i. Okay? Sorry about that. This would be 4i. So 4i times 4i is 16i squared, which would be the same as negative 16. So I combine here to get negative 3. Negative 3 times 4i is negative 12i. Combine here to get negative 12i. And since we know that this thing is a 0 over here, we should 4i times negative 12i is negative 48i squared, which is the same as positive 48, which when canceled gets me a value of 0. All right, perfect. Okay, so we've got this right here, but once we have a 4i, the rule is that we can then plug in the next value, which is negative 4i. Cool. So we plug in negative 4i. Got that there. We bring down the 1. We bring her down. Okay. 1 times negative 4i is negative 4i. By the way, if the second time you get an I down here, something went down. Okay, you might want to just check that out. Okay, something went wrong. But this becomes a 0, so we're good. 0 times negative 4i is 0. I combine here to get negative 3. And negative 3 times negative 4i is positive 12i, which, just like we talked about earlier, gives me a remainder of 0. So it says write this function as a product of linear factors. Because it's x to the 4th, we know we have 4 solutions. 1, 2, 3, and 4. With 1 being 4i, we could say, okay, this is x minus 4i. But remember, the second one will always be its conjugate, which is positive 4i here. And what we have left is x squared, number with an x, number by itself. That's what the I is for. So we've got x squared plus 0x minus 3, and I set it equal to 0. So now I say, okay, what can I do to solve this? Simply add 3, take the square root of both to where x is equal to plus or minus root 3. And that right there, my friends, is what we would have for both number 1 and number 2. Okay, as far as 3 and, well, really 3 and 4 for our solutions of this polynomial. Cool beans, very good. Okay, I've had no questions here, but that doesn't mean you don't that there are no questions. Feel free to continue to throw those out there if you've got any more or different ones you want me to look at. Until then, we'll continue by going to number 13, which states find all the zeros. And again, it is a non-calculator question. So we do the factors of 2 over the factors of 3, understanding that we're looking for 4 solutions, right? Trying to look for 4. So we've got the expression of 2 over 3. The factors of 2 are plus or minus 1, plus or minus 2. The factors of 3 are plus or minus 1 and plus or minus 3. And so we'll go to each value. So we'll do 1 over 1, 2 over 1. Okay, so we got 1 and 2. We then do 1 over 3 and 2 over 3. So plus or minus 1/3, plus or minus 2/3. And that right there, those are the 4, well, really the 8 possibilities that we have there. So at this point, we're going to put in synthetic and try to test it out. So we've got the coefficients of 3, 8, 6, 3, and negative 2. So let's start off with, let's say, a value of 1. So we're going to bring her down. We've got 3 here. 3 times 1 is 3. In fact, let's go negative 1. I'm trying to, sorry about that. I'm trying to envision this. Wow, messing up here. Okay. All right. Wow, this is good stuff. Okay, let's go negative 1. Boom. Okay, so we're gonna say 3 times negative 1 is negative 3. This would be 5. 5 times negative 1 is negative 5. I add to get positive 1. Multiply to get negative 1. We get 2 here. 2 times negative 1 is negative 2. Even though it looks as though we're really close, we're still not quite there. So we'll skip 1, or negative 1 at least. Okay. Let's try negative 2. Okay, so we bring down 3. 3 times negative 2 is negative 6. Add to get 2. 2 times negative 2 is negative 4. Add to get 2. 2 times negative 2 is negative 4. We get negative 1. Negative 1 times negative 2 is positive 2. And, oh, looky there, we have a 0. So our first 0 we used was negative 2. So we've got 3, 2, 2, and negative 1 as our simplified expression here. So negative 2 we have as a 0. So we'll put that in as x plus 2. Now, let's look at the next one here. I believe we could look at another one by, let's see, we could plug in like 1/3. We could do that. Let's plug in positive 2 maybe. Ooh, how about trying to see if one that maybe we could get here. I guess we could do 1/3 or 2/3. We could try that. Let's try 2/3. Cool. We'll try to be a little resilient. Try this out. So we got 3. So 3 times 2/3. I'm gonna have to do this on the side. 3/1 times 2/3. 3's cancel, giving me a value of 2. So we're gonna put 2 here. In fact, we'll make it negative because we've been in luck. So we're gonna say -2, right? Because we got -2. This would be 0. 0 times anything, 0. 2 plus 0 is 2, and 2 times -2/3. Yeah, that doesn't work, does it? Yeah, it doesn't work. Let's see. Okay, so we've got that one. Let's do +2/3. So let's try that again. +2/3, we did it over here, would be +1. Okay. No, that still wouldn't work. Well, let's try it. You're bring down to 3. This would be 1. Actually, that might work. 2 plus 1 is 3. Okay, so we got that there. 3 times, we already did it, but 3 times 2/3 is 2. 3 times 2/3. Oh, actually, this would be 2. I think I messed that up. Sorry, y'all. Trying to do this out. I'm messing up. Okay, so try this one more time. Let's go. I'm going to try the negative version one more time. I think I messed up. So bring down the 3. 3 times 2/3 is equal to 2. Cool. And when it's negative, really, because that's what we've got here. So we're going to say, no, I did that right. That'd be -2. Okay, not quite there. All right, so that doesn't work. Yeah, that one doesn't work. I was thinking it might. What about -1/3? Let's try that one. Again, I'm not looking at the answer key on purpose. All of these things that I'm doing, it's not that I'm failing. I'm just trying some new things. This is the same thing you would do on the test, okay? So we bring down the 3. 3 times -1/3 would be -1. Okay, so we got -1 here. 2 plus -1 is 1. Okay, 1 times -1/3 is -1/3 here. Yeah, that's still not going to work. Okay, maybe you could help me out with it. I was trying to see if there's one maybe we could use. I wonder if -1 would be an answer. Do we do +1? Bring down a 3 times 1 is 3. 5. No, 5. No. That wouldn't be it there. Huh. Did I do this right? 3, -6, 2. I'm making sure I wrote this down right. As you look at it, maybe you could help me out with this. Did I write it down right? Let me see. I'm gonna check this out. Again, once I get to this, if I got to a point where as I tried some of these out wasn't working or whatever, again, I'm not using a calculator with these fractions. Maybe that would help too. On that, you could use a 4-function calculator to just do the fractions. That's okay. You absolutely could do that. I'm trying to see just if I could. Maybe if I plugged in +2/3, would that work? Let's see. Did I try +1/3? Let's try it. Okay, 1/3. Bring down the 3. 3 times 1/3 is 1. 2 plus 1 is 3. 3 times 1/3 is 1. 2 plus 1 is 3. 3 times 1/3 is that's much better. Okay. So we've got 1/3 that we could have plugged in for. I think I did -1/3 and wasn't thinking. But my 2 zeros, my solutions are x plus 2. And you could either put 3x minus 1 or you could just say x minus 1/3. That would be the same exact thing. So now I take 3, 3, 3. So I have 3x squared plus 3x plus 3. I factor out a 3. So I got x squared plus x plus 1. I can't actually factor this. So From the simplified version or from the part up here, I think it'd be easier here. We do the quadratic. So negative b, or negative 1, plus or minus the square root of b squared, 1 squared, minus 4 a times c, 1 times 1, all over 2 times 1 or 2 times a. So this would be negative 1 plus or minus the square root of negative 3, because 4 times 1 is 4, 1 minus 4 is 3, negative 3, all over 2. So you could keep it as this with an I on the outside, or you could put the 2 to both and say negative 1/2 plus or minus I squared of 3 over 2. So the big thing is just continuing to battle with it a little bit. And these two would go here and here in terms of the plus and the minus. Okay. Woo, that was a good one. Good problem. Good problem there. All right. Let's go through. Oh, there you are. Pauline, you came through in the clutch there. Great work. I was trying to check and see. And just there was a couple of them that I just missed them. Okay. Number 4. Let's do that one. And love the questions that are being thrown out there. Continue to ask questions if you've got any specific ones that you're like, well, coach, this one's one that we really need to do. And remind me, and we can go through that together. Number 4 is a good one. And so I want to make sure we hit on that one together. All right, let's read it. Number 4 says, graph the following function. Then it gives the following information that's here. And I'm going to take a picture here just so I've got it. I had a couple of them on here, but I didn't have all of them. So we will put these on here. Okay. That one's one I already did. All right, so we're going to graph the following equation. And first thing is it's hard to graph something if you don't know the characteristics. So the step 1 is to first identify the characteristics of the graph by first factoring. So we could take out an x on top. When I do take that x out, I get x plus 3 on the top side. On the bottom, I could take out an x. And what I'm left over with is x squared minus 3x minus 18. So we're going to keep simplifying on the bottom to get x times, I think when I factor this, multiplied to negative 18 but added to equal negative 3, it would be x minus 6 and x plus 3. Okay? So we could then say, okay, what can be canceled? Well, I think I did this in another class. This one's tricky because I could cancel this one. I could also cancel the x values. And yes, just because x is on the outside and it doesn't have a value with it doesn't mean that I can't cancel that. So I've actually got 2 canceled values producing a simplified expression of 1 over x minus 6. So what can I do with this simplified? Well, I'm going to end up having actually 2 holes. Okay? 2 holes. So the x values that get canceled, that right there, here and here, we set that equal to 0 to say that it's 0. Okay? Then we set x plus 3 equal to 0. And when I do, I solve for x to get negative 3. Okay? Now, to find the y's, what I'm going to do is plug 0 in for x and negative 3 in for x, and then just see what happens. So 0 gets plugged in for the simplified x to get 1 over 0 minus 6, or negative 1/6. So this is going to be 0, negative 1/6 as a whole. Negative 3 gets plugged in. I get 1 over negative 3 minus 6, or negative 1 over 9. So I go over negative 1. Negative 3 is negative 1 over 9. And we've got a hole here and a whole value here. Okay. So what do I do now? Well, I've got this expression circled up on top, and I ask myself, what is my vertical asymptote? What could make the bottom equal to 0? And so I set x minus 6 equal to 0, and when I do that, I get a value of 6 right down below. So I've got 6 as my vertical asymptote. Remember that if it gets canceled, it can't be a vertical asymptote. It only can be a hole. So just a heads up on that. I then look and see, okay, based upon my domain will be always all reals, except x cannot be equal to what makes the bottom equal to 0, which would be my vertical asymptotes as well as my holes, and only the x values of those holes is what I'm talking about. So we would say x is not equal to -3, 0, and +6. So it's all reals, except x cannot be equal to -3, 0, and +6. Now I then look at my horizontal rules, which, by the way, make a note card. That's smart out there. Put a little note card out there. The horizontal asymptote, you could do it over here or over here. We'll do this simplified, but you could do the same over here. The degree of the top is 0. The degree of the bottom is 1. So my question is, okay, so if the degree is greater on the bottom than the top, then my horizontal asymptote will be y equals 0. Okay, y equals 0. So what we've got here is a vertical at 1, 2, 3, 4, 5, 6. Sorry, this should be a dotted line. And a horizontal at y equals 0. So we've got one running across. That means on the bottom left-hand side, well, first off, if we have a horizontal, the slant asymptote will not be there because you have to have 1 degree greater on the top than the bottom. Greater on top than bottom. The only exception to that is when simplified, if you got y equals x plus 1, that would be that. Yes, technically the degree on the bottom is 0 and this is 1, but you wouldn't in that case have a slant asymptote if there's absolutely nothing on the bottom. So just a heads up there. Okay, so that excludes this one. So as we graph this, we could go to the x-intercepts, which if this is equal to y, so we have y equals 1 over x minus 6. For the x-intercepts, let's plug 0 in for y. So we would say 0 is equal to 1 over x minus 6. And we solve for y by distributing that x minus 6 on both sides right there. Okay? So actually, let's do it over here. Here we are. So we got x minus 6 here and here. These cancel, giving me 0 equals 1, which is not equals. So 0 is not equal to 1. So we would say that the x-intercept would be none, right? We have none. You could put an x there. You could just say, whatever that just designates that there is none. Now we look for the y-intercept. The y-intercept, we could plug 0 in for x. And when we do that, 0 goes in for x. We get 1 over -6, so -1, 6, which, oh, by the way, is the same as the hole. So this down below is really not a point. It's a hole in the graph because that's the part that got canceled up above, okay? All right, now what happens here? Well, we know since the 2 holes are on the bottom side, there's 2 zones, left and right of this vertical asymptote, right? You see that there. There you go. Whoop, right there. All right, so since it's to the left side, kind of down below, this graph is going to connect here. Still going to have a hole in it. But as it fights this way, it's just going to kind of slowly drop. Cool? And as it goes upward, it can't go past this line, but what it can do is whoop, just like that way, and goes closer and closer to that horizontal asymptote that's there, okay? Now, the only thing we need is what is this right side doing? The zone, I call it zone 2, where this is 1 and this is 2. So to find zone 2, we're going to plug in a value of 1, 2, 3, 4, 5, 6. Let's do like 7 in our T-chart. So if I plug in 7, 1 over 7 minus 6, which is 1 over 1, which is 1. So 7 would be a value of 1 here. So since we've got a 1 point up above, it's still going to try to fight downward, but it can't because it's approaching that horizontal. It's going to try to fight to the left, but it can't because it's kind of coming towards this vertical, and we would leave it just like that in terms of finding the graph of the rational expression. Okay? Oh, great question. Can something be a hole in a vertical asymptote? The answer is no. Once it is canceled, like right here, the x plus 3, it is no longer a vertical asymptote. It is only allowed to be a hole. What I do first is factor and simplify. Anything that cancels both top and bottom, we automatically say is a hole there. Okay, anything left over with the 1 over x minus 6, we set the bottom, the x minus 6 equals to 0 to then say what the vertical asymptote is there. Okay. Oh, good question. How do I know what points I plug into the t-chart? That's a really good one too. Good question. I already have 2 holes down below here in zone 1, right? Where we know the graph is going to be on the bottom left because of the fact that the holes are below that horizontal. So we're good there. But we don't know what's to the right of this x equals 6 line, right? This x equals 6. But what I can do is I usually plug, if I want to find one to the right, I just plug the value that's to the right of 6. So you can do 7, 8, 9, whatever you want. But we just want to plug one value in. And when I do, I get 7 in for x, and then we get 1 out for y. So we put 7 comma 1, which would be right here. And because of that, we would then have our rational expression right up on the top right. Okay. So that's how we would get there. Great questions. These are great questions, and ones that are really, really, really good. Okay. Do y'all have any other questions? While you're doing that, I'm going to pull up slant asymptote one. I'm going to do one more. I think I only put one on the review. That's why I'm going to do this one here. Oh, yeah, this is good. Okay, I'm going to do this one if it's cool. Cool by you. X squared minus 3x minus 4 over x minus 2. X squared minus 3x minus 4 all over x minus 2. Okay. First thing is we simplify, right? So what 2 factors can be put in the top? Well, I could put in -4 and +1, right? So we have x minus 4 and x plus 1. On the bottom, we're left with x minus 2. Okay? All right, so we've got this here. Let's go through the questions. Nothing can cancel, so that means we eliminate this whole feature here. The degree on the top compared to the bottom is greater on the top than the bottom, so we eliminate the horizontal. The vertical, we set the bottom equal to 0 to get x equals 2. So we got that there. Let's go y-intercept. We plug 0 in for x. So we would say, okay, 0 minus 4 times 0 plus 1 all over 0 minus 2. So we got -2 on the bottom. And the top is 1 times -4, which is -4. So we'd get a value of 2. So we would say 0, 2 is my y-intercept. Let's look at the x-intercept by plugging 0 in for y. So we would say in this, we would set 0 equal to x minus 4 and x plus 1 all over x minus 2. And I can multiply both sides, top on the right side and the left side, by x minus 2. So we cancel here. We get 0 on the left side. So 0 equals x minus 4 and x plus 1. And we set both of these equal to 0 to get x equals 4 and x equals -1. So I would say -1 comma 0 and 4 comma 0 when I set both of those equal to 0 there. Okay. So we've got that part. What is my domain? Well, it's all reals except x can't be equal to what my hole is, which we have none, and my vertical asymptote. So it can't be equal to 2. Okay. Again, hopefully this is helpful. Just want to get one more rep on a slant asymptote, but correct me if there's something that you just need me to focus in on. Okay. All right. Now I'm going to erase all this so I could show you this next part, because this is the big part. Okay. So there was nothing canceled. So I'm going to take this out, because for our last part within our slant asymptote, we have 1 degree greater on the top than bottom. After I simplify, which we can't, so we simply divide the bottom into the top. So it should look like this. X minus 2 goes into x squared minus 3x minus 4. What times x gets me x squared? Well, that value would be what? yell it through your house. It would be the value of x. And then what do I do with this x? Yes, very good. I feel like Dora the Explorer. Sorry, it's my fault. X times x would be x squared. X times -2 is -2x. We change the signs here and here. So where -3x plus 2x would be -x, bringing down the -4, okay? Now the question, what times x gets me -x? Well, the only difference is the sign. So we just put -1. -1 times x is -x. -1 times -2 is +2. We change the sign. We could continue. Here's the deal. Whatever you get as your remainder, we don't care. Just don't care. So your slant asymptote would be y equals x minus 1. Okay. All righty. Whew. All right. So I'm starting to lose my voice today. All right. Between teaching, coaching, and this, whew, this is fun. Fun stuff. All right. Vertical asymptote is x equals 2. So we got it here. My x-intercepts are -1, 0, and 1, 2, 3, 4, 0. And my y-intercept is 0, 2. That's helpful there. So we've got all this mess. Now we've got to graph this. Now remember the -1 stands for my y-intercept. So we're going to put -1 here. My slope is mx plus b. So my slope is m, which is 1. So I'm going to rise up 1 over 1. If it was like -2, that means I go down 2, right 1, right? But yeah, it doesn't. So we go up 1 over 1. And so this thing should look something like this right here, okay? Now this is where it gets a little weird. We have two zones, right? Compared with this vertical asymptote, we've got one graph to the left of this and one graph to the right of this vertical asymptote. Now, how do I know what it looks like? This is the kicker. This is the tough part. This graph right here is going to go fight to the right, but it can't because of the fact that this vertical asymptote's in the way. This part is going to try to come to the left or down, but as it goes, it approaches that asymptote, and then we just connect them, okay? This one is going to do the same thing. To the left side, it's going to try to fight to the left, but just can't. And it's going to try to go up, but it just can't quite do it. Again, it's an asymptote that creates a like a crack in the graph right here that it can't quite pass, but it approaches, and that's how you would graph it. Okay. All right. Throw out some questions there. I've been talking for the last 35 minutes. I know there has to be some questions out there, specific things that you might need to go over. If you do, let me know. As you're thinking about that, if I said write this polynomial in standard form, you would first put 3 different values or 3 different factors because of the fact that there's 3 here. So this 0 would be x, -2 would be the opposite of x plus 2. -4i is x plus 4i. But remember the conjugate rule, which states that if we have -4i, we have to have positive 4i, which changes the sign to that there. Now, remember to distribute here and here, and here and here. And then once I do, I'll distribute these two together at the end. So just be sure of that when you are solving. All right. Oh, yeah, I do want to do this calculator one. I may end with this and any questions that you have, which is number 2. And to help with number 2, I'm going to put in the expression, okay, x to the 4th plus 10x to the 3rd. I'm going to show you my calculator in a second, just in case you're like, Coach, come on, Coach. Well, I'm coming. X to the 3rd minus, delete that. Plus 5x and minus 66. Okay, I'm going to graph this. Okay, so I'm going to show you, I'm going to kind of get rid of this here. Oh, what's up, y'all? Good to see you. All right, let's go to this part. Okay, so when I go to zoom standard, normally this does the trick, right? And in some regards, it does help for sure. It definitely does help. But you'll see that it goes through +2, but there's no other values that are there. Well, what I could do, if this is a calculator problem, just to double check, is I'll zoom out. So I'll go zoom out, and I've got to press enter one more time to see where this is at. The kicker, though, is that we don't know what this value is. So we know that this one's 2. We don't know quite what the left one is. We could probably guess by kind of moving that cursor over to the left and seeing that it's probably close to -11. But just in case, we'll go to second trace. We'll go to 0. And when it says left bound, what we want to do is try to go to the left. You see how this left bound's right here? What we want to do is try to do the best we can of getting a value on the left bound, even though I can't see the cursor, which kind of stinks, I know. Even if you wanted to, you know what we could do? Just zoom out again. Let's see if that will work. Okay, kind of, sort of. You see it here. Okay, so like when you go like second trace again, when you go to 0, let's see if that will. Okay, there's the cursor. So you see the negative right here, this negative value. And I guess you could adjust this. But my whole thing is, I'm going to go back to zoom standard, y'all. I'm going to show you what I'm going to do. I'm going to do this a little bit different. I'm going to zoom out real quick. Okay. You're going to see it twice. Okay, so when I go to second trace, even though when I hit 0, you can't see the cursor, we know that the X value is here when the Y value is here. So I want something that's to the left of this, which is positive. So I'm looking for this Y to be positive. Once it's positive, that means that's the left bound. So it's still negative. Right there. There it is. 863. So -11.5 is about over here. And then that would be the Y value. So I'm going to say enter on that. Your right bound should be the value that's negative for Y. So I just pushed over to the right once to get -130. And that means it's below the X. That's the right bound. And then my guess, a lot of times I just click it there again. And there you are. There's the 0, -11, 0. So what do I do with these? Well, I'm glad you asked. My friends, I'm glad you asked. So we're going to take our values. If I can pull this up, sorry. And I'm going to plug in for synthetic. We're going to plug in -2 or -11, 2. So we're just going to plug those values in. -11's here, and I'm going to go through this fairly quick because we've already kind of done this, right? Pretty good. So we bring down 1, multiply to get -11, and all I'm trying to do here is trying to figure out what the other solutions are, right? So this gives me a 0, which should be good there. You could also, if worst came to worst, you could plug in possible zeros in, right? If you got 1, you could kind of go from there. We're going to plug in 2. So you got 1 here. 1 times 2 is 2. We got 1. So again, all I'm trying to do here is trying to simplify to where once I get x squared plus x plus 3, I can't factor this. So what I do with this is just do the quadratic formula. So x equals -b. B is 1, right? -b. Plus or minus the square root of b squared, 1 squared, minus 4a times c, which is 3, all over 2a, which is 2. And so I could just simply just simplify this to get -1/2 plus or minus. Inside this is -11, so I root 11 over 2, and you could just leave it as this. That should be 11 there, okay? But that would be a good example of how I would attack it using a calculator and approaching it that way. Hey, I hope this was helpful. It's 40 minutes of a great review, going over some questions or anything else that y'all needed. I just appreciate y'all's hard work. Just know that it is definitely not unnoticed. I know a lot of you put in a lot of hours and time to put your best foot forward, to do the best of which you're capable. And for that, I am most proud. Not the grade. I know that a lot of times it's the grade that you want. But just coming in from a coach's perspective, coming from a teacher's perspective, even more than a coach's perspective, is that the best thing I can say is that you just give your very best. That's all I expect, and I believe that's all God expects. And so keep working, keep pushing, keep grinding. I'm right there with you. Tonight was a good example. We grinded together as we struggled through problems, as we struggled through some of the issues with technology. But just know that I'm here next to you, walking right there beside you, okay? All right, care about you. If you need some more help, come in tomorrow morning from 7:15 to 8. We'll check some problems out. Other than that, have a great day. Bye.